All right, we are doing proofs for trig functions now. So let's just kind of review again really quickly. Cosecant is 1 over what? Sine. Secant is 1 over cosine. Cotangent is 1 over what? Tangent. Sine is 1 over what? Cosecant. Yeah, you might not have thought of it that way, but you need to think of it that way. That way, when you're doing proofs, you can be very flexible. Cosine is 1 over what? Secant. And then tangent is 1 over cotangent. Okay, and another way of finding tangent or talking about tangent is what over what? Okay, sine over cosine, and then cotangent is cosine over sine. Good. Okay, now we're going to look at our unit circle, and then from our unit circle, we're going to derive the Pythagorean identities. So let's say that we are talking about a 30-degree angle. So we're talking about this 38-degree angle, and I can draw my triangle like this, right? Okay, so this is 30 degrees. We know this is 30 degrees. How long is this part? How long is that? Square root of 3 over 2. How long is this part? Huh? 1/2. So if you know the answer, just please say it. How long is this one? Huh? 1. It's a unit circle. It has to be 1. The radius is always 1. So since this is a right triangle, Pythagorean theorem applies. So we know that a squared plus b squared has to equal c squared because this is a right triangle. Let's say that a is the x part. We would say that is square root 3 squared. B is the y part, and then so we can say that's 1/2 squared. C has to be the hypotenuse, so this has to be 1 squared. So let's verify and see if we actually get the same number on both sides. So we get 3 over 4 plus 1 over 4. What does that equal? 1. So that works, right? So this is kind of the proof. Now, what is another way to say this square root 3 over 2? In terms of sine and cosine. This is 30 degrees. So what is this side in terms of 30 degrees and sine and cosine? Yes, cosine 30. Okay, so this is going to be cosine 30 degrees squared, right? A squared. Okay, so what about this 1/2 part in terms of 30 degrees? Yes, sine of 30. And that's equal to 1. Okay, another way to write this is saying cosine squared 30 like this. So the square on the outside, another way to write that is put the square inside. And then plus sine squared 30 like this is equal to 1. Good? Okay, now I don't have to use 30 degrees. I could also use 45 degrees, right? Now 45 degrees is another right triangle. And I can do the same thing. Cosine 45 degrees squared plus sine 45 degrees squared is equal to 1 squared. Yes? Okay, and I can also do 60 degrees, right? It would give me the same thing. Therefore, this angle can be anything. So it could just be just angle. As long as the angles are the same, we will always get this theorem. So this is the first one you have to memorize. cosine squared plus sine squared equals 1. This is the basic one. If you don't memorize this, you cannot do any proof. Cosine squared plus sine squared is always 1. If you cannot remember that, please start from your unit circle. All right, first one. Cosine squared plus sine squared is equal to 1. Second one, we're going to manipulate this basic theorem to get our other two. So the first thing I'm going to do is I am going to divide everything by cosine squared. Okay, let's think about this. Cosine squared divided by cosine squared is what? 1. Sine squared divided by cosine squared is a little bit tricky. Sine divided by cosine is tangent, and there's a square, so tangent squared. Okay, 1 over cosine squared. That's the same as 1 over cosine. What is 1 over cosine? Secant, so this is secant squared. So this is the second one you have to memorize. 1 plus tangent squared is secant squared. If you can't get it, it's okay. Go back to the original one. Cosine squared plus sine squared equals 1. Get to the second one. All right, now let's get to the third theorem. So we're going to, instead of dividing by cosine squared, we're going to divide by sine squared. Okay. Cosine squared divided by sine squared is what? Cotangent squared, very good. Cotangent squared plus sine squared divided by sine squared, 1. And then the last one, 1 divided by sine squared. Yeah, cosecant squared. Okay, so this is the third one you have to memorize. Now, I don't like to memorize it in this form because I just want to see a pattern. So one thing about math, if you want to do well in math, is you want to find a pattern. Once you find a pattern, memorize the pattern. Some things there's no pattern, you make a pattern or you make a story. That way you can help yourself memorize it. So I can see that the second one is 1 tangent secant. So I want to just change this. So it's 1 cotangent cosecant. Okay? That way it's always 1 and something and something. So for you, you might want to come up with a story to help you remember. So kind of see that this is 1 CC, right? The two C's come together. Cotangent comes first. Same as the first one, 1 TS, tangent comes first. And they're both plus, so that's kind of easy to remember. All right, now we're on to the next thing. Okay, so let's look at the graphs of sine and cosine. Sine is the blue one, cosine is the red one. How far apart are the graphs from each other in the x direction? Good, pi over 2. They're offset by pi over 2, right? What about tangent and cotangent? How far apart are they? There's a flip, but if you flip it over, how far apart are they? Yeah, pi over 2. And then the third one, if you look at secant and cosecant, how far apart are they? Pi over 2. So you can see everything is offset by pi over 2, right? So technically, we can get from one function to the other one by pi over 2. Therefore, there are these co-function identity. So if you want to get to cosine from sine, you would do pi over 2. So this is the way the function is written. Oh, sorry. It's going to be sine pi over 2 minus theta. I'm going to write all the c's first. So, maybe I'll write this first. So sine theta is the same. It's going to be cosine and then pi over 2 minus theta. So this is how you're going to remember the relationship between them is always pi over 2. And to get to the other one, it's pi over 2 minus the angle. Okay, the other one is the same. Cotangent is tangent pi over 2 minus theta. So what do you think tangent is going to be? Tangent is going to be cotangent what? Yeah, pi over 2 minus theta. What about cosecant then? Cosecant, what do you think is going to be? Secant? Guess. Pi over 2 minus theta. Good. And then secant is going to be cosecant pi over 2 minus theta. As long as you remember the relationship, you can write these yourself. You don't have to copy it down, right? You just know it's pi over 2 minus theta and the two graphs that are the most similar to each other. All right. Now, let's review. Odd and even. Odd function means f of negative x is what? Let's see if you remember from like the first 2 chapters of the year. F of negative x is same as negative f of x. Yes, negative f of x. Even function. F of negative x is equal to f of x. How do you know something looks like an odd function?
When it rotates.
You rotate around
The origin.
180 degrees around the origin. And then how do you know that it looks like even?
When it reflects over the
Y-axis, yes, correct. So now if, I'm going to let you figure this out. You have 6 original trig functions. You're going to figure out which one is odd and which one is even by just looking at it. All right, let's vote. Sine. If you think it's odd, raise your hand. Okay, yes, it is odd. Cosine. If you think it's odd, raise your hand. Even? Okay, good. All right, now we're getting to the tricky one. Or tricky ones, sorry. Tangent, odd, raise your hand. Even, raise your hand. Okay, odd, correct. Cotangent, odd, raise your hand. Even, raise your hand. Okay, odd is correct. Cosecant, odd, raise your hand. Even, raise your hand. Neither? Okay, it is odd. And then last one, secant, odd, raise your hand. Even, raise your hand. Okay, even. All right, let's go ahead and categorize them. Odd and even. Okay, we have some odd ones, right? We had sine, tangent, cotangent, and cosecant. So since they are odd, they must follow our odd proof, right? F of negative x means negative on the outside. So sine of negative must equal negative sine. Right? This is the proof of odd identities. Negative on the outside is negative on the outside. Okay. The second one is tangent on your graph, but basically if sine is odd. Its reciprocal must also be odd. Because they're related. Oops, sorry. Okay, the other two that are odd are tangent and cotangent because they're reciprocal of each other. So tangent negative x is negative tangent x. And same thing with cotangent. Cotangent negative x is negative cotangent x. And the only ones that are even are cosine and its reciprocal. So cosine negative x is no negative. And same thing with secant. Secant negative x is no negative. All right, so we learned a lot so far. We had our Pythagorean identities. There are 3 of them. Do you remember what the first one is?
Oh, it's cosine.
Cosine squared.
Theta plus sine squared theta equals to 1.
Good. All right, and then we had 2 other ones that come from them,
Yeah.
right? Okay, and then the second thing we learned was
1 plus tangent squared theta.
okay, so those belong to the Pythagorean. So those 3 belong to the Pythagorean.
Oh, okay.
The second kind we learned was cofunction. They're all offset by pi over 2. Yeah, they're all different from each other by pi over 2. Okay? The third one we learned is odd and even. Okay? We're going to use all 3 of them to help us prove some stuff. All right, let's try this. If cosine is 0.34, find sine of theta minus pi over 2. Find this. How does that relate to cosine?
Oh, because sine. Oh, wait. That's theta.
Okay, so look at your notes for the cofunction. What does it say?
It's theta minus pi over 2.
Cosine equals sine what?
No. Pi over 2 minus theta.
Pi over 2 minus theta. That's a little different. So I can't really make a direct substitution, right? How do I make the question look like my cofunction?
Oh, switch the data.
Okay, I can switch them, right? So I can switch them.
And then take the negative out.
Take the negative one out.
And it
Yes.
would be negative sine.
Oh, hold on. Too fast. Okay, so now I'm going to take that negative out. So it becomes pi over 2 minus theta, but it's not exactly the same. Now I have to use my odd and even identity. Sine of negative something is the same as what? Is sine odd or even?
Odd.
Odd. So negative inside means outside. So we're going to take that negative and then put it outside. Does that make sense? We're trying to make it match because all I know is cosine is this number and I can't figure out what the sine of theta minus pi over 2 is. So I'm going to try to use all my identities to maneuver to get there. Okay, so what does this equal? Negative cosine. Because this part is cosine. Does that make sense? Okay, so then, what does this equal? Negative 0.34. So you solve all that with no calculator. All right. Okay, really quickly, let's have you try the next one. Okay, what is the answer for the next one? Yeah, 0.45. It's exact substitution. Okay, let's have you try this next one and let me know when you're done. Okay, so cotangent negative theta is this. We know that cotangent is an odd identity, so we know that this we can write it like this. So that means cotangent is negative 7.89. Now we want to find tangent of this that is close to a cofunction but not quite. So we need to change it. So we already know that we are going to take the negative out so we can switch the order. And again, tangent is an odd identity, so you take the negative out. So negative tangent of pi over 2 minus theta. That's equal to minus cotangent theta, and I should not have changed it because negative cotangent is 7.89, so that is just 7.89. All right, we're gonna start doing some proofs. So the thing about proofs is you gotta be creative and think outside the box. So you got to be really flexible with how you think so that you can try different things until it works. Okay, so let's try this. Simplify the expression sine cubed x plus sine x cosine square x. We're gonna simplify this. So, do you see anything about the first and second term that's kind of interesting to you?
Yes.
Hold on. You're going to count 5 seconds before you answer. Okay, so what do you think is interesting or that stands out to you about the first term and the second term? The first term is cube. Okay, what's that? Okay, you guys have to talk a little louder. I can't hear you. Huh? The second one has cosine. Okay, what do they have in common? Sine. So if I see sine in both, what is one thing I can do? Not divide.
Just take it out.
Take it out, factor it out. Okay, so I'm going to take out sine x. If I take out sine x from the first term, what do I have left with?
Sine x. Oh wait, I meant
Sine
square x.
Squared.
Oh, yeah,
Yeah.
square.
Okay, plus. The second term, if I take sine out, what do I have left with? Cosine squared. Now let's recall. What does this equal to? 1. So this answer is sine x. So what you want to do is look for these key things. Oh, they look like there's something repeating. Trifactor. Okay. Try this one. What does it stand out to you? Like, what is it kind of, hopefully your algebraic ability is to recognize some patterns. So what does this one kind of remind you of, hopefully?
I don't know the name, but like one's positive, one's negative.
Yes, one's positive, one's negative.
So
It's like foiling,
yeah.
so it's like the difference of squares,
Yeah.
right? So if I multiply these together, what do I get?
Secant x squared minus.
Secant square x
Secant square x.
minus 1 over sine square x. Does this look somehow familiar? It does? Okay, recall your identity. 1 plus tangent squared is secant squared. How do I get to secant squared minus 1 from there? Move the 1. Tangent squared is secant squared minus 1. So, can you guys finish this?
Yes.
Okay, go ahead and finish.